Alright. Are we up? Alright, we're up. Alright, let's roll into it. Let's get into it, I guess. I'm just gonna keep busting it out. Busting ass. Wait, we got audio? Yeah, we got audio. I'm gonna keep busting ass on this model. Modeling it in CAD. In SolidWorks. So, let's do that. Let's get it open. It's going. It's doing its thing. Alright, give it a minute. Give it a minute. It's doing its thing. Can I move it? No, I can't. Alright, let's make something. Let's finish our project in SolidWorks. Well, perhaps I'm not going to finish it, but we're going to get close. I got to get some more base models in here. Download them from the internet, probably. And then I can think more about where to go next with it. Okay, it's popping up now. Alright, here. Let's see what happened. Display station, bang, transition. Okay, here we are. Alright, we're back in SolidWorks. Let's open our previous files. File. Bot ass. That would be the one, bot ass. Bot ass. Okay, we got bot ass up here. Oh shit, I just ran into my PC. Alright, and it's looking pretty good. Now we can run the axle through there. That's just another part. Can I just add like insert component? Do I have to go through all that? Sketch. Or can I sketch in here and make a new component? Is that a thing? Insert component. Otherwise we can sketch. Okay. Exit sketch. I can't do an extrusion though, huh? Alright, fuck that. What is that buzzing? Can y'all hear that? Is that rendering on your end? Alright, anyways, okay, so I need to make, okay, what the fuck, that's at a weird angle, shit, I don't think I like this model, can I rotate this? Whoa, it's starting to rain. Okay, exit sketch, motherfucker. Alright, let's get back into our, open recent, let's go back to frame, bot, that's bot, back to bot. Yeah, we can do that. Back to bot. Okay, we got more to do here. So I can add the axle and shit, but do I want to do that? I don't want to do that. That probably want to be different parts in the assembly. I don't want them to be merged. Okay. What about that though? That would be a good thing to know. So can we insert, extrude? Can we insert something? Oh shit, the wind's really picking up right now. Feels so good though. It's so hot here. It's like 90 degrees. So it feels good. Okay, shit, motherfucker. What were we doing? Okay. Alright, I want to see if I can insert something. I gotta figure out the dimensions. I don't know the dimensions of that part, which I downloaded from the internet. So, open, recent, open, make drawing from part, make assembly from part, blah, 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 print, blah, 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 mode. What? Insert, here we go. Insert, curve, reference, part, insert part. There we go, above frame, pressure, tutor, no, none of these. Internet model, shock absorber, base, top rod, nut, base. Yeah, okay, so that should do. The template used for making the derived part has different units of measurement than that of the base part. Do you want to change the unit measure of the derived part? Do you want to change the units of measure of the derived part? The template used for making the derived part has different units of measurement than that of the base part. Well, fuck, it's called base. So convert custom property values of the derived part to the units set in the template. Change the units of the derived part to the units of the base part. I think that was what I wanted. Okay, so right, looking at this plane, we got him perfect. Okay, what fuck? I already messed up. All right, go again. Perfect. Okay, and how do we get a measurement on him? Feature sketch. Smart dimension from here to here. What do we have? Smart dimensions. Reference dimension. Here we go. 0.98. Okay, 0.98. Alright, that's technically all I needed. So let's start features, extrude boss base. Let's work on him. Working on him. We want to start in the center. Let's see. Yeah, we're just essentially gonna go like this and mirror. So okay. Something like that. Right, and then we're going to do our smart dimensions and get that bitch exactly what we want. So 0.38, 0.98, so what, like 0.4. Let's go 0.4. 0.4, okay, and then now my distance here to here, well, here to here. Okay, cool, we can do that. 0.45. So half of 0.98, half of 9, 4, 5, half of 8, 6, 4, 5, 11, 5, 1. 0.51. That's not half of 9.8. What the fuck? Wait, what? 9.8, 4, 5. What am I? I'm retarded, right? 4, 5. 4, 5, half 8. 0.06, 4, 5, 6. 0.456. 4, 5, 6. I'll just go 6 then, because we'll give it a little space. Okay, cool. All right. Yeah. Oh, I didn't hit fucking check, bro. Oh well, I don't think I need to. Okay, now we extrude him. That's a good question. That's a really good question. Enough though. Want to extrude him enough? 1 inch. Where does that put us? Would that be enough? Probably. Okay. I like it. Check. Okay, now I want to mirror this guy, but I want to bodies to mirror. Ooh, that's right, because we merged him. Fuck me. Cancel. Go back. Exit sketch. It's not gonna do it. Extrude. This guy. 1 inch. Do it. Looks good. Do not merge. No merging. No merging. It's not doing any good for anybody. Okay. Okay, now we can do a mirror. We're going to mirror face plane. faces to mirror, bodies to mirror. This guy. Okay. Well, first we have to pick a reference reference plane. This guy. 0, offset, check, mirror, bodies to mirror. This guy. That's it. Check. Okay, now we're gonna go ahead and extrude boss base. We're gonna choose this guy. I hope I'm doing this in like an optimal way and this isn't, you know, I'm not really like messing this. I don't know. I'm not doing it in the dumbest way possible. I hope that's not the case. Okay, that's gonna be 0.5. Wait. Yeah, should be. Wait, 0.5? Wait a second. Oh. Oh no, I don't know how thick this is. I gotta find it. I gotta figure it out. Wait, so reference here. Smart dimensions, vertical. .85. So 0.85, 0.8425, 0.425, 0.425, and then now that's 1. Oh, okay. Shit. Check. Now that's 0.5, right? Yeah. Check. 0.58, half inch, 0.58. We'll do it. Oh, it'd be the same as him. I wonder what he is. That's fine. That's fine. Okay, now that's a check. Okay, exit sketch. Now it's gonna give us a boss extrude, but I don't want to actually do that. I want to do features, extrude cut. Through all. That's it. Check. There we go. Okay. And then now, of course, let's round off these edges. I can't choose those also. That's fine. Let's see. Point. Meh. 0.3. I like that. Check. .3. Check. So that should do it. That should do it. That should do it. Well, should I add the axle and shit in here? Nah, not really. Not really. I need to do that though. So let me see. Let's see what I can get here. Whoops. Let me see what I can find. Go back to what's my history? Let's go back to this thing. Back to the grabcad.com. Grabcad.com. Let's check out the grabcad.com. And let me do a search. Tutorials. I'm gonna probably need to use those. Library. Here we go. Library. And I want to look up worm gear motor. See what kind of shit comes up. Yeah, that's what I would like right there. Man, I can really just download stuff from this. That's so beautiful. Alright, cool. We're about to get another model off the internet. My motor and my motor model. It should work good. Because I got to design a mount for it. So let's extract these. Whoa, where did it just go? Here we go. Extract all. Browse, put it in its respective folder. Bang. Extract. Bang. Okay, cool. Let's try to insert it. So, insert features, insert part. Internet model, shock absorber. Wait, whoa. Internet models. It's not here. Why is it not here? Internet models. It's right here. Because it's not a part. It's a assembly. It's an application. Okay, so save as. And now it should save as a part. Yeah, save as Okay, now if I close this, file, insert part, and we got it here. How big is it in comparison? Oh, cool. That's what I was expecting. No. Yeah, I just need the measurements really, so then we can delete it. Okay. Oh, this is so good. This is really so good. Okay. Holy smokes. Okay, sketch. Smart dimensions. Do we got a circle, like a center here? Can I get a center? Reference dimension, indeed. Okay. Yeah, that's what I need. Annotation cannot replace an existing annotation views. A new annotation view will be created and named as. Okay. I don't think that's a problem, right? I don't know. Okay, 0.82 though, from the center to the bottom. That's what I needed, 0.82. Okay, so let's exit out of that. Let's go to our other view. I'm hitting the arrow, brother. This one. Okay. Sketch. Yeah, sketch. Onto here. Smart dimension. Why can't I get the center to pop up? Doesn't really matter. I just need a dimension. So wait, okay. How the fuck? Okay, that's what I would do. Okay. I got it. So let's go. And then we'll follow that. Okay, so something like that. Okay, now we go smart dimension. Bang, bang. 0.82, 0.882. Okay, and that moved. That's exactly what I want. Okay, so check. 0.82. Okay, now we got this. Now we got this. What do we want to do here? Okay, we want to shorten the length of this. Smart dimension to be 2. Where does that put us? Oh shit, we moved that side. Okay, I don't want this side. What the? Nah. It went away? What the shit? What happened to it? Whoa, it just keeps fucking moving. Okay. Let's get rid of that thing. Delete. Exit sketch. Delete that motherfucker. Delete. Yes, delete. Okay, let's try again. It's just we are gonna have to be this way, so. Okay. Smart dimensions. Ah, shit, I didn't put a circle here. .82, make this dimension. Cancel. What the fuck? Why? Shit. Shit. I don't know, I'm not fucking liking it. Sketch 2, because I made it all part of one sketch. Shit, exit sketch. I'm not liking it at all. Yeah, delete it. Okay. Oh, man. Extrude. Okay. Extrude boss space. Exit sketch. That's not what I want to do. Sketch. Sketch. Sketch on here. Circle. Give me the center. Perfect. Just a circle. It doesn't fucking matter. Exit sketch. Okay. Features. Extrude boss space. No, I don't want to extrude him. No. Boss space. Why does it just go to that? No. Fucking go back to sketch then. Sketch. On here. Bang. Bang. No. Here. What the fuck? Bang. Okay. Bang. Okay. Bang. 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 Why is anything different this time? Why is anything different this time? Sketch. Okay. Now it's doing, I think, what I want it to. Okay, well, this is becoming fucking absurd. So, this is becoming fucking absurd. Delete. Get the fuck out of my face. Delete. Yeah, delete that shit. Alright, what the fuck? Does it need to... I don't know. I don't know. What the fuck? What the fuck? What the fuck? Bro. No, I'm not gonna delete that. That needs to go. Why is that? What the fuck? Why is that at a fucking angle? Holy shit. What is that thing? Oh, whatever. Okay. How do you... Bro. We can't... Why is that? We can't get rid of that dimension? Solid bodies. I can't get rid of that fucking dimension. I can't believe it's at an angle like that. Hide. Alright, whatever. Get rid of it. That's fucking unbelievable. Cancel. Like, what the fuck are you talking about? Okay, sure. I just want to literally just want to record the dimension, you stupid bitch. Upside down. Upside down. It couldn't have just fucking turned around normal. This isn't even fucking normal. I mean, bruh. Is that a straight line? It is. It is a straight line, 0.75. Now what? What's the fucking distance from here to here? It can get, well, it's gonna get all weird on me. Are we still? We're still in smart dimensions, right? Fucking give me a measurement, huh? It's not going to. It's not going to. Point. Okay, I didn't ask. 0.79. 0.79. Okay. 0.79. 0.79. Alright, 0.79. Okay. Alright, 0.79. Okay. 0.79. 0.79. Is this why? Point 7 9. 0.79. I not on this fucking thing? What happened to my, why did I like stop editing my sketch? The fuck? Why did it stop editing my fucking sketch? What is happening right now? Like, can I not do this? Am I fucking incapable of doing this? Yeah. Rectangle. Maybe because I'm skipping fucking steps and not clicking shit. If it would give me a center point, that'd be good. That'd be great. Perimeter circle. Shut up, faggot. Yeah, my bad. Nope, that's not what I wanted. Center point, midpoint, whatever. Center point, midpoint. I just want somewhere to fucking do the thing from. Holy shit. Holy shit. I'm gonna spend hours on this part, on literally just this fucking portion. What the fuck? I'm gonna spend hours on this portion. Why, what the fuck? I can't move it. Is it because it's fucking attached here? Why can't I fucking move it? Extrude boss base. I'm a fucking, oh dude, why can't I fucking move it? Maybe because I'm fucking touching that. There, I don't know, something like that. I still need that fucking line too, center point. Oh shit, Wait. I didn't even click this. Nope, redo it. Fucking redo all of it. Nope. Don't think for a fucking second it's gonna fucking work. Okay, so now we go here. Let's not touch anything. I don't want to touch shit. Fucking go like that. There. Pussy. Bang. Okay, put it down. Smart dimension. Nope, can't do a smart dimension. I don't have a fucking line. Center point line. This. Show up, bitch. Okay. Was that it? It did not look like it. Center line. Show up. Center. Yeah, to there. Okay, smart dimension. Can I not do this still? Okay, point, well, I don't even fucking remember, 7.9. That's what it was, 0.79. Okay, like that. Okay, check. We gotta put our checks, okay? I'm not putting my checks, and this is really getting me. Okay. Now him. Where do we want him? Him with... him. Yeah, okay, you know what, that's fine. Like this. We want that to be 0.45. Too much. How about, so 0.5 looks like, okay, it's a huge difference. 0.75 is better. Let's move it back, 0.7. 0.68. Okay, like that. And then now we can make him, because it's going to move from that point, 1.8, 1.5. That's probably it. Alright, that's probably it. Okay. I haven't been clicking check on any of these. Oh my gosh. I'm gonna fucking lose it. I haven't been clicking check on any of these. Okay, fine. Exit sketch. Do we like this? What's our thickness? Oh shit, what did I just do? Smart dimension. Thickness. 0.22. 0.25. Yeah, like that. Okay, cool. Check. Fucking check it. Exit. Alright, is it gonna give me an option to extrude? Of course it is. Yes. No, I don't know. I don't see that thing anymore. Oh well. Merge results. We'll do it. 1 inch. We'll do that. Sure, that works. Okay, I like it. Okay. No. I guess whatever for like shits and gigs, right? That's nice. Wait a second. That's nice. That's nice enough. Yeah. Is that what I want right there? A little less, though. It gotta be less. 0.2. Yeah. Oh, yeah. That's what I'm talking about. Okay. That would go there, and that would go there. I mean, that's not like full on. That's not a full on support, but like we're getting there. We're getting there. I don't know exactly how it's gonna attach. I guess here we can move that down and see it. Does it? It doesn't really have points of attach. Oh, well, are those? Oh, that's it. That's where it would attach. Okay. Okay, we can do that. Yeah, easy. Do that and then figure out how that'll go on there. Okay. Let's get to a trimetric view. And that would go on there, do his thing. Okay, so I'm going to base. I should be able to move him down. Like that, and then wait, what's that? Oh, okay. And what if I go like that? And then I save. Okay, let's try that. Let's go to open recent. Let's go to bot ass. Models contained within the assembly have changed. Would you like to rebuild the assembly now? Yes. Okay, look at that. So now we got everything on here. We're going to introduce that other part. Fuck. So what is this now? This guy. Assembly. So him. I mean, he's all weird. I can rotate it. I'm not sure. How do I get to a good view? And I don't think those aren't even matched. This is a shit model. I'm gonna have to use a different model. Anyways, let's go assembly. Let's do mate. We're gonna, oh, we can't click anything about him. Oh wait, cancel. Nah, mate. This guy. Wait a second. Let's mate that guy. Mate. This guy. To that guy. Man. Wait a second. Come on. Let's get it right. I don't know. The outside one then? This guy. To this guy. Man. Okay. Let's concentric. That should do it. Advanced analysis, mechanical, hinge, gear, rack and pinion, screw, universal joint. It's not a universal joint. It's more like a hinge. Why doesn't he go there though? Tangent, concentric. Well, I want concentric, but I want concentric and tangent. Add a new folder. Sure. Add this. The selected mate cannot be. What would you like to do? I would like to cancel, and you should fuck off. Okay. You know what? Let me get rid of this assembly. Okay. Delete. Yeah, fucking get them out of here. Okay. Insert components. Browse. Let's do internet model, shock absorber, assembly base. Let's start with let's do it in parts. We'll do it in parts. Okay, come here, baby. Come here, baby girl. Do this one. Let's do this one. Okay. Bang. Alright, that's really nice. Let's do... Are we still mating? We are. Let's do this face. And this face. And... That should work. That should work. That should work. Are we inside of there? Did I not make that? How did I not make that shit wide enough? Fucking motherfucker. It's not. Oh well, it'll do for now. It'll do for now. Save document. Sure. Let me save. I can't save. Let me get out of that. Save. Whatever. Okay, that one. Let's introduce him to let's see how this works. Okay, so far away. Mass properties. Look at that. That's sick. Basic assembly mate. Mate him to him. Can we get him over there? That's fine. Kind of did it in the wrong way. Wait, that's fine. Okay, so now, is that the one with the, yeah, it is. So now can we put him up against him? Okay, we're close. We're close. Check. And then now I want him concentric with him. Yeah, I figured it couldn't fucking do that. We can't get... No, cancel. Whoa, that line... That was fucking crazy. Holy shit. Man. That was fucking crazy. Why won't you two touch? Perpendicular, parallel, coincidence. On a tangent, boy. That ain't gonna work. Okay. That ain't gonna work. That ain't gonna work. Holy shit, that was fucking crazy. I don't know, I don't have my axle in place right now, so I don't know how to get it there. Oh, what the fuck? Center line. Wait a second. Mate or center line? Planar face on which to create a sketch for the entity. Nah, that's not it. Mates. What does it think concentric means? Cause it ain't fucking... How is that concentric? Like, am I missing something? Where do you see the mates? Yeah, that's them. Is he gonna move? No. What? Do it. Why? I don't get that. That don't make any sense to me. And then how the fuck? That don't make sense either. Shit. Move component. Nice. Whoa. Why is he here? What the? Okay, I can't move him. Move component. Rotate component. Oh, now I can. There's something like that. Whoa, why is it inside? Here, let's, why is the view like this? View. Display. Oh, here. This is what I wanted. That's almost perfect. Move. Alright, pretty much like that. Something like that. Something like that. Okay, cool. Whoa. Oh, did I remove his? Maybe I removed something. Some sort of mate on him. Yeah, maybe that's what I did. Okay, I want to add the rest of his parts. Alright, go away. Insert components. Browse. Shock absorber, base, assembly, spring, top rod, nut, spring, top rod. I assume. Oh, it's facing forward now? Okay, look at that. Beautiful. Well, I can rotate it. I kind of want it to be like facing the same direction as the other one though, ideally. I think that's how you typically find them. Although, what, you can just rotate it actually, right? You can just rotate those shits. Like in real life, you can rotate them. Yeah, I like that. Let's, component, rotate, component. Can I rotate free drag about by delta XYZ? Rotate around, I think Z, 90? It didn't work. I would have to do like the whole thing. Top rod. Yeah, here we go. What? Is there a transformation? Open part, appearance, edit part, suppress main view, components, and copy form, blah 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 blah. Here maybe I can just. Alright, here. Let's go from the top. Well, I don't fucking know. Okay. It's not moving. What? It's not moving. Okay, what the fuck? Why? Oh, because it's mated. No. No, it's not. That was different. That's the top. That was the base. I'm trying to move the top rod. Why? What the fuck? It doesn't rotate. It doesn't fucking rotate. Oh, fuck you. Okay. Now it rotates. Okay, so let's do it now. Let's do it now. That's good enough. Okay, check. I like it. Mate. Not the top rod. Cancel. Mate. This fade. Well, first we'll do him. Him. Did I just mate that? What the fuck are you doing, bud? Thought I just clicked mate. How many fucking times do I have to click it? Yeah, there you go, buddy. Check. And then, do I not get a chance to do that? I guess not. Whatever. Okay, there it is. Alright, cool. I kind of need to. I kind of got to do it. I mean, I know that ain't the face, though. I just want the face. It's not the face, though. What? Yeah, sure. Something like that. Okay. Holy fuck, I can't see anything. Okay, there. Okay. I mean, that's pretty good. That's pretty good. Alright, check. I can insert the rest. Spring. I don't fucking understand that thing. Uh, no. Not quite. Let's try it. Not quite. No, I don't like any of it. Oh, now it's gone. Alright, oh well. Kind of get the point. Move component, rotate. Okay, it's rotating that way. Fuck me, man. Fuck me, man. Oh, it's already rotated. Okay. Concentric. Yeah, check. There. That's okay. That's how it's done. Okay, that's how it's done. So we're getting somewhere. We're getting somewhere. So now what if that one doesn't rotate? So now if I do a rotate component, will he rotate? No, he don't. He still rotates. I wonder why. F. Okay. Yeah, it's something like this though. Something like this. No, it's not what I want. Rotate. I don't like he's rotated too much. No. Something like that. Now we save. Okay, whatever. Rebuild. Yeah, so something like that. Okay. We have a lot to model still. A lot to model, and then I have to figure out how to simulate everything, and whew, lots to do, but it's good. It's good. I feel as though, we progressed pretty far. That's great. That's really good. What are you guys thinking? How's it looking? Does it look like dog shit? Be honest, it's okay. You can tell me if it looks like dog shit. But I think it's doing alright. We got so much to do still. Yeah, that'll hold the electronics, a battery. Let's see what we can find for a battery model. That was awesome. Thank you so much for that. That's probably what maybe it might be the right size for what I need. We'll see exactly. Library. Let's see what we got for lithium iron phosphate batteries. LFP. Okay, rechargeable battery. That's pretty much what we want. How much is it though? 12.8 volts. We don't have any specs for it. I wonder how big it is. 206 amp hours. Oh shit. That should do it. 206 amp hours. Let's try it. I want to see how big it is. Alright, let's see how this looks. It'd be the lithium iron phosphate battery. Let's see. Extract all to the right destination. Alright, so I did the same thing. We're gonna have to open it. Okay. File, save as. Internet models. New folder. LIFEPO4. Battery. Save. Let's close this. Let's insert component. Browse. Oh. Nah. 206 amp hours, huh? Nah. Wait, what the fuck? That's a big battery. Right? 6 inches? No, I guess my shit. I guess I made my shit tiny. How much does that thing weigh? Oh, let's see the other one. Yeah, that one's undoubtedly smaller. 100 amp hours, 50 amp hour. Okay, let's do this one. This is way better. Yikes, that's ridiculous. I wonder what that's used for. But also my shit might be small anyways. Okay. We'll do the 50 amp hour for now. That's what we'll do. Wait, this in assembly? That's at application. Close. Don't save. Okay, I'll just try to insert it into here. Right. Nah. STL. Yeah, perhaps. SolidWorks. Battery bolt. Yeah, that's the big one, right? 100 amp hours. Design study. Handle. Nah. Let's try that again. Yeah, and then we just save the assembly. Yeah, it'll be good. Okay, so save as blah blah blah. Internet models. We'll just save it right in here as an assembly. That'll work. Yeah, and then we'll just post it in the other one. Close. And then we just post it in here. Let's get a good view. Trimetric. Here we go. Insert. Browse. Disassembly. It's 250 amp. That's the one. Damn, for real. 12 volt, 50 amp hours. So is my shit that small? Yeah, I guess so. It's tiny. I made my shit tiny. Okay. Yeah, like that's even larger. Okay. So I'm gonna have to make it a lot bigger. Okay. Alright, cool. Oh, what should I do? Some circuits? How's something else I gotta do too? Okay. I gotta fix my resume also. Yo, this is crazy. My build is far too small. I didn't realize. What do I want to upgrade this right now? It's pretty easy actually. I'm starting to get familiar with the user interface, so it's feeling good. Let me check my stream to see the quality of it real quick. Let's see what's happening. Nice. Okay, cool, cool. Cool. Am I recording? I am. Okay. Wait, okay. How the fuck? I'm just watching back a little bit. Let's see what happened. Alright, well, that motor is probably far too small to drive this thing then. Holy shit, it's way too small. Okay, so that's what I would do. Okay. So let's see, what else do we have? I don't know if this is the kind of motor I want to use, though. Alright, now I'm seeing some pretty decent designs on here. Much larger. Maybe because I'm fucking touching that. 0.2 kilowatts. 200 watt, yeah. One gear motor, 0.2 kilowatts. What various ones do they have? Oh shit, oh shit. Wait. I didn't even click this. That's pretty much what I want. I want like 100 watt. That's probably good enough. 100 watt is probably good enough. Let's see, 100 watt. Oh, right here. 1 kilowatt. Let's not touch anything. I don't want to touch shit. Fucking go like that. There. Dang, I wonder how big that is though. That's probably large. Damn, I was getting mad. I was getting frustrated. Do this one. Let's do this one. Okay. Bang. Alright, that's really nice. Let's do. Are we still mating? We are. Let's do this face. And this face. And. Those are 3-phase though. I don't want that. I just want DC. Okay. Whatever. Okay, that one. Let's introduce him to. Let's see how this works. Okay. So far away. Mass properties. Look at that. That's sick. Basic assembly. Meet him to him. What was the other thing? Linear guide. Yeah, that's it. Shit, bro. That would be it. Okay. I mean, I'm pretty much finding models of almost every component which I need. I just build the frame essentially, or model the frame myself, which would be fairly easy. That was fucking crazy. Holy shit. That was. Well, I got the lightning. No, cancel. Whoa, that lightning. No, cancel. Whoa, that lightning. Oh, that's crazy. That lightning was crazy at 42 minutes and 30 seconds of this stream. That was crazy. Alright, yeah, they got the linear guides and everything. CNC milling machine. Man. Wow, this shit's crazy. It's like, yeah, 6 inches in width. It's a big battery. That's 50 amp hours. Yeah, it's probably realistic though. Center line. Wait a second. Mate or center line? Planar interface on which to create a sketch for the entity. Nah, that's not it. Mates. What does it think concentric means? Because it ain't fucking. How is that concentric? How that just totally defeated the. Oh no, it didn't. Wait, what the fuck? Made it up. 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 Oh, what in the fuck? Yeah, that line and this line. And it does that. And it fucking does that. Parallel. Perpendicular. Coincident. Yeah, coincident, but fucking spin the thing, man. Okay. That's just ridiculous, but whatever. Let's see. Rotate component. And let's move to what? Top view. Do it. Bro. Why? Get the now make any sense. Shit. Move component. I mean, that's not doing shit. Whoa, why is he here? What the? Can't move that. Move component. Rotate component. Oh, now I can. There, something like that. just fucking around now. Why is the view like? Oh, here. This is what I wanted. That's almost perfect. Ah, shit. I don't know. I don't know what else to do right now. I do have a lot of work to do, but like, I think I'm gonna take a break from this. Okay. File close. Yeah, I think he's saved, right? I'll save him again. File close. SolidWorks. File exit. Okay. I'm a wanderer. I'm a wanderer. I get around, round, 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 round. I'm a wanderer. I'm a wanderer. I get around, round, 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 round. Alright, that was pretty good. I don't know. Let's do some circuits. Let's do some circuit theory. I get around, 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 around. I'm a wanderer. I'm a wanderer. I get around, 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 around. I'm a wanderer. I'm a wanderer. I get around, 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 around. Alright, I'm getting set up here. And then we move on to some circuits. Let's see. Let's go to... I'm just getting some circuits up so we can work some theory. Let me change the title too. I think that'd be better. Update titles. What should we change it to? I don't know. What should I call it? Electronics. Just learn electronics. Nah, electronics. Electronics and engineering. Electronics and engineering. Description, learn the theory of circuits. And build your own. Comma, and build your own. Something like that. I don't know. Who cares? Who gives a shit? Update. Facts. 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 Modules. Let's see what we got on. Inductor, RC circuits, RL circuits. Let's just start here at the RC circuits. Okay, yeah, we're on here. That should be fine. Let's move to this station. Bang, transition. Okay, looking good. Alright, doing some circuit theory. We're gonna work on some RC circuits. Okay. I think I've already done this. Oh yeah, I definitely have. Okay. Recalling this, yeah. Various problems here. Do we want to do this shit? I don't want to do anything right now. Fuck it, let's go. Let's see what some other people are up to. I'm gonna go to kick. I'm kind of bored right now. Sneeko's on. Let's see what the fuck he's talking about. Bored right now. Kick. Yeah, but we're gonna do the circuit theory too. Get started. What the fuck is... Who cares about that question? Follow. Okay, buddy. Okay, buddy. Get out of my face. Bro, what? Kick website isn't working. Get started. Next. What the fuck? And don't ask me questions. Alright. We got to switch. It's a RC circuit, remember? Alright, 40 kilo ohm. Let's see, 1 microfarad. 20 kilo ohm. 5 micro ohm. Farads. Shit. T equals 0. Our switch is going to flip open. 15K. Of T, right? We're doing a transient analysis. Okay, so 0 and then we disconnect. Okay. In our equation for RC circuit, like we can go ahead and derive it, but what's the purpose of this, right? Let's just write it down. So VC of T equals V infinity plus V naught minus V infinity. I believe so. I believe this is right. Multiplied by e to the negative t divided by RC. Or tau. We could say tau, but tau equals RC. Right, okay, so this is our equation here. These 2 points here. Alright, so at t equals 0, we're charged up. So what is going to be our charge over our capacitors at t equals 0? They're going to look like, after a long time, the switch has been closed after a long time. Okay, so a DC analysis, essentially. So it's just going to look like a voltage divider with our initial voltages being across these 2 resistors right here. So let's redraw our circuit that's going to look like this. Our 15 volt supply, 15K. Then we're going to have this voltage divider right here. $15K, $20K, 40K. Okay. 15 volts. Okay, so multiplied by 20, 15, 35, 40, 75, 75K. Okay. Equals. I'm just gonna use my phone. I got it right here. I don't know where my calculator is. Fifteen times divided by 75. 4. Okay, wait. 15, 35. Right. I just want to make sure 75. Okay. 4 volts. VC2 equals 15, 40 divided by 75 equals times 8 volts. Okay. So that's our initial values. And after T equals open, we're separated from the supply, from the 15 volt power supply, voltage supply, and then we're just going to be left with some voltage across these capacitors, which they're going to discharge into the rest of the circuit. So it's going to be open there. We want to know V naught, the voltage across there. So our new circuit's going to look like this. And these are our 2 points, positive, negative, V naught, which we're looking out for the time. Or looking out for the voltage of, which is respective of the time, right? Time dependent. Okay. What are our values again? 5 micro, 1 micro, 20K, 40K. Okay, so now using this formula, we're going to have through KVL, we're just going to have a superposition, right? So we're just going to add these two voltages together, the voltages that are across the resistors due to the discharging of the capacitor. Right, so VC1 of T equals V infinity would be, it's going to discharge, so it's going to go to 0. So V infinity equals 0 plus, we start with 4 minus 0 e to the negative t divided by RC, which is going to be 20K times 5 micro. Zero point 0.1 equals, again, 0 plus, this time we're starting with 8 though, minus 0 times e to the power negative t divided by, this RC is 1 micro times 40K. Is 0.04. Negative 0.1, wait. 10. Negative 1 divided by 0.04, that's 40. $25. Right, so if we used KVL and we went around this loop, whatever, we went around that loop, we would say that V naught minus, those voltages developed across the resistors, which are these 4e negative 10t minus 8e negative 25t equals 0. Therefore, we can just say that v out of t equals 4e negative 10t plus 8e negative 25t. And that should be the result. Negative 25, 4e negative 10 volts. Yes, volts. Volts. For t greater than or equal to 0. Okay, just like that. Just like that. All right, let's move on to the next one. Let's do some more. This one requires a Thevenin equivalent, or no? Maybe the next one. Maybe the next one. Okay. Alright, so initially only this capacitor charged and it's at infinity, right, a DC analysis. Therefore, the voltage across it will be that voltage divided by this series resistors. Let's see, so if we write the voltage divider relationship, we can say VC of 0 equals 120 volts multiplied by this ratio of 80k to the sum 80 plus 40 is 120k equals 80 volts. Okay, so V naught is 80 volts, right? Going back to our equation. Okay, so at t equals 0, this switch closes, this switch opens, right? That was a short circuit anyways. This switch opens, this one closes to this side, and then now we're going to be looking at this portion of the circuit. We can redraw that to get a better visual. $25K and 40 nano. So just like this. Okay, what do we want to know? We want to know the voltage across this guy. Okay. Which is the voltage across the capacitor also. And we know that the voltage across the capacitor of t as a function of time equals V infinity, Vc of infinity plus Vc of 9 minus Vc of infinity. T divided by, we'll put tau this time, which is RC for this circuit. Okay. So what's happening here? What's happening here now? So right, so what is our, we have our initial value, what is our final value? Right, that's the question. What is our final value? So after a long time, again, it'll look like an open circuit. So what is that voltage developed across this resistor if we were to just consider this an open, just an open circuit? So I think we would say that Vc of infinity would equal then 6 milliamps multiplied by 25 kilo ohms would equal 6 e to the negative 3 times 25 e3, 150 volts. Okay, is that true? Is that true? Would that be an open circuit? Indeed, we're not going to say it's a closed circuit. That would be okay. Let's just want to make sure. Okay. 150. But it will be opposite. If it's going in this direction, it will indeed be opposite. Infinity equals negative 150. It's going to develop in the opposite direction. Okay, negative 150 volts. Negative. Because we can only have a voltage drop across the resistor, correct? And so if this current is flowing in this direction, then that would make this the positive side and that the negative side. Okay, and then so a negative voltage in reference, in comparison, if we're looking at the capacitor, it's positive, negative like that. Therefore, it would be a negative voltage drop across it, essentially. A voltage rise then in comparison or in reference. Anyways, okay, so now we decided that. So let's plug this into the equation. So Vc of t equals infinity, which is 80. Wait, right? No. Negative 150. 50 plus 80 plus 150 e to the negative t divided by, now our RC is going to be 40 nanofarads times 25k. 40 e to the negative 9 times 25 E3. 0.001. Sure. $1,000, right? Okay. All right. So final answer. That's gonna be 230. E to the negative 1,000 t volts for t greater than or equal to 0. Yeah, okay, that's it. That's the answer. All right, moving on. This one requires a Thevenin equivalent, so I find it much more interesting. Bro. a delta. Okay. Originally we're here, and at t equals 0, the switch flips to this side. T equals 0, flip to that side. Okay, now we have a dependent source involved. Alright. So initially this capacitor is going to charge up through this, current divider. So we have some current division going on here, so it's going to look like this. It's a part of the division. Yeah, I want to do that. I delta depending on that. So it's just an open, yeah, okay, so it's just an open. So, okay, our initial circuit's gonna look like this. So is it gonna just look like the voltage developed across the one resistor? Is that what's going on here? That's an open circuit, yeah. There's not gonna be any current flowing through this. So after a long period of time, it's just gonna look like VC 0 equals 8 milliamps times 10K. volts. Okay, and then now we're gonna find the Thevenin equivalent of the next circuit, this portion here. So it's gonna look like this. And our capacitor is the load. So We'll call it negative I delta. 20k times negative I delta minus 100 equals 0. We have 3 unknowns and 2 equations, so now we can say what? Well, since this is an open circuit here, we would also say that I1 equals I1 plus I delta equals 0. I1 equals negative I delta. Yeah. So we can solve for I delta, V Thevenin minus E3 I delta minus 80k negative I delta equals 0. 80k times negative I delta plus 20 times negative I delta equals 100. So 20, 80k, that's 100k, negative 100k, I delta equals 100, I delta equals negative 1 amp, equals negative 1 amp. Oh, that's 100, 1 milliamp, right? It'd be 1 milliamp. 100 divided by 1,000. 100,000. Shit. Yeah, 1 milliamp. Okay. Negative 1 milliamp. So V Thevenin minus 30 minus 80. Wait, 33. Yeah, 33. Yeah, that's 30,000. Wait, 33 plus 80. 50 minus 50. Wait, plus 50. Okay. I delta equals 0. $50 volts. Okay. Okay, so I gotta short the independent voltage source, and we're gonna do a test source. So next circuit will look like shit. Shouldn't have done that yet. Oh well. So this is our V test and 1 volt. Okay. I want to know IT, and then VT divided by IT gives me my R Thevenin. So okay, so I1 equals plus 20k, 20 divided by 80. Wait, 20 E3 divided by 80 E3. It's the same thing, 0.25. 0.25 I delta plus, yeah. Okay, so which is 1 volt. Here, I'll put it in there. 1 minus 33 I delta minus 80k times 0.25 I delta. Can you see that? Yeah. So negative 30, 80 E3 times 0.25. 20,000. Negative 30,000 minus 20,000. 1 minus 50. Okay. Plus 50k. Wait, plus 53. Negative 5 amps. So I1 equals 0.25 times that number. 5E negative 6 amps. And then IT equals the sum of those two, which is plus 25 microamps. So R Thevenin equals 1 volt divided by 25 microamps equals 40k. 40 kilo ohms. And then we'll attach the capacitor. Right, so this will determine now we have our RC and then we have our final voltage, which because this will essentially become a open circuit after a long period of time. Our DC analysis, as T goes to infinity, the capacitor will look like an open circuit, and therefore no current will flow. There will be no voltage drop across this resistor, and our voltage will just assume 50 volts, or capacitor voltage will just assume 50 volts. Okay, so anyways, where's VC naught equals 80? So our equation becomes RC 40. What is my capacitor value again? 5. nanofarads. Bang. That's it. Oh, wait. Volts. Bang. Alright, that's the answer. Okay. Alright, this one looks a little more complicated. Let's try this. How's that title? Electrical engineering student drowning. Absolutely drowning. The fuck? Bro. Okay, so initially our circuit, the voltage developed across the capacitor is due to this voltage divider here. So if we just write that out, so VC initial is going to equal negative 75, right? Look at the orientation of this voltage source. Negative 75 multiplied by our resistor is in parallel with the 10K, so 10K divided by 25K, the sum of the two resistors. Now that equals negative 30 volts. Alright, so that's our initial voltage. Now let's look at our circuit after t equals 0 and our switch flips to this other node here. So we're disconnected from this voltage source and we're connected with this current source and this resistor network. So it's going to look like this. We'll redraw it. That's still focused, dude. Okay, so now after a long time, if this is an open circuit, our voltage across the capacitor as t approaches infinity, right? As t approaches infinity, because it's gonna level out, it doesn't increase forever. But so the voltage across the capacitor as t approaches infinity, right? Remember the properties of the capacitor. As t approaches infinity, the capacitor looks like an open circuit. If this were an open circuit, there'd be no current flowing through this resistor, therefore there'd be no voltage drop across it, and the voltage developed across our capacitor would just be the voltage developed across this 5K resistor here. So it's simply going to be 5 milliamps multiplied by 5 kilo ohms. Right, 25 volts. It's going to be positive, yes, because it's a voltage drop. Positive, it would assume a positive. Like that. Okay, so 25 volts. Okay, so infinity, 25 plus 0, negative 30 minus 25 e to the negative t divided by RC, which is yeah, so if this was an open circuit, what our RC would be, what's going to be our R? Imagine, because it's a resistance perceived by the terminals of the capacitor. And so if we're to find the complete resistance perceived, we would convert this into 0 amps, which would be an open circuit, no current flow. And we would simply have these two resistors in series. So 25K. So 25K, 25 E3 times 100 nanofarads. Okay, so 0.0025. 55. Okay. Alright, and it says, what are the questions? The initial voltage on the capacitor, negative 30. The final voltage on the capacitor, positive 25. The time constant, 2.5 milliseconds. R Thevenin, indeed. 2.5 milliseconds. That is true, yeah. That is 2.5 milliseconds. Okay. And then now, the length of time in microseconds required for the capacitor voltage to reach 0 after the switch is moved to position B to reach 0. Okay. So now we just plug it in. So if we want to know the time it takes to achieve 0 volts, we would just say Vc of t equals 0, because we're going to be solving for time. 25 minus 55 e to the negative 400 t. So negative 25 divided by negative 55, negative 25. Negative 25 divided by negative 55. So 0.4545 equals e to the negative 400 t. Natural log. So we'll say, so negative 400 t equals natural log of 0.454, we'll say 5. We'll simplify more. Can you see that? Yeah. Natural log negative 400 t divided by, so t equals negative 1 over 400 natural log of 0.455 equals the time it takes for the capacitor to reach 0 volts. Negative 1 divided by 400 multiplied by the natural log of 0.455 equals 1.97 milliseconds. And that is correct. That's it. That's it. Okay, there's only one more problem. So yeah, let's go ahead and do it. Whatever. So it's initially closed. Yeah, and that's the voltage developed across this resistor, which, what is its value? 50k. So it's gonna look like this. So we'll just make it into a simple current dividing circuit. So 7.5 milliamps. So I1, we'll call it I1. That's gonna be the current through here. I1, 7.5 milliamps multiplied by 80k divided by, so we have 20, 50, that's going to be 70k, so our equivalent equals 80k in parallel with 70k, which equals 80. Wait, that's not how it works. No, it'd just be 80 plus 70, right? 80 plus 70, 150. Four milliamps. 4 milliamps. I'm pretty sure it's shit. That's it. That's close enough. That's it. Yeah. 4 milliamps, and so VC of 0 equals 4 milliamps multiplied by 50K. Equals. Okay. Yeah. And then after it's open, all we're left with is this. That's just it. Yeah, that's it. Okay. And then so infinity equals 0. RC is 0.4 microfarads times 50K. Milliseconds. The numerical expression for after the switch is opened. Yep, that's it. Alright, cool. Well, that was a conclusion of the RC homework. Next, we'll move on to the inductors. And we'll do more there. But I think I've been going long enough. I think I'm going to call it here. Thank you so much for joining me. Thank you for being here. Until next time.